Hello everyone. The topic for today is scientific notation. Right now I want you to pause the video so you can copy down your notes and then resume when you're ready. So the key for scientific notation is it is always going to be some number times 10 and then whatever exponent is needed to make that number. This number always has to be between 1 and 10. Like, that's just the rule. If you have something that's above 10 or below 1, then it's not proper scientific notation. So what I mean by that is you're going to have to plug in this number and that number every time. And this number is always going to be a 10. So that's a given. So looking at an example of taking something that is in standard or scientific notation and writing it in standard decimal form or decimal notation, we've got 7.2, that's our number between 1 and 10, and then 10, and then the exponent here is 4. So that 4, being that it's positive, is telling us that we are going to move the decimal to the right. So anytime we have a positive exponent in this case, that means we're moving the decimal to the right. So we've got 7.2, and we're just going to add a few zeros after it just so that we can kind of see the place values. And we're moving the decimal 1, 2, 3, 4 times. So we are left with 72,000. That would be our answer. That's standard decimal notation. For our next example, we've got 3.82. Again, that's our number between 1 and 10. And then we're multiplying by 10 to the negative 7th power. Since that exponent is negative, that means we're moving the decimal to the left. So we've got our 3.82. And since we're moving to the left, we're going to put a bunch of zeros in front of it. And we're moving the decimal 7 times. 1, 2, 3, 4, 5, 6. Didn't have enough zeros. 7. So we're left with that as our answer. That is the standard decimal notation of that number. Now, in order to write a number in scientific notation, again, like I said, it's always going to be some number between 1 and 10 times 10 to some exponent. Well, here, in order to, if we were going to place the decimal anywhere to make this a number between 1 and 10, we'd have to place it right there. That's the only place we can place it to make it between 1 and 10. So that's 2.892. We've got to use all of the numbers that are not zeros. And then we have to tell, you basically have to tell me how many times do we have to move the decimal to get back to where it started? Well, if I put the decimal right here, I've got to move it 1, 2, 3, 4, 5, 6 times in order to get back to where I started. So that means the exponent is 6. So there is our scientific notation. Same thing with the next example. If we're going to make this between 1 and 10, that decimal would have to be between the 1 and the 2. So it would be 1.2. Again, it's always times 10 to some exponent. Well, if that decimal were here, we're going 1, 2, 3 spaces to the left. So that means that our exponent is -3. That's how many times it took to get the decimal back to where it originally was. So there's our scientific notation. A couple more examples looking at problem number 7. Okay, we want to write this in decimal form or standard notation. So 4.9. And again, since it's a positive exponent here, we're going to add some zeros here to the right. Well, we're moving the decimal 5 times. 1, 2, 3, 4, 5. So it winds up right there, which means that our answer is 490,000. Number 8. Our exponent is -5, so that means we got to add some zeros to the left of our 4.9. So we're going back 5 times. 1, 2, 3, 4, 5. So our standard notation looks like that. Now I want you to solve problem 9 and 10. Bring those answers along with any questions that you may have with you to class tomorrow.